Now whenever we throw something like ball upwards, so when it is going upwards, so initial velocity, whatever is the starting velocity is known as initial velocity, that is equal to u, and it starts going upward. As it goes upward, the speed goes on decreasing, and at a particular value, at a particular distance, the speed completely stops. Therefore the final velocity over here will become 0, that is v. v will be equal to 0. कोई भी बॉल समझो, अगर अपन बॉल को ऊपर फेंकते हैं तो शुरुआत में जो वेलोसिटी से अपन फेंकते हैं उसको इनिशियल वेलोसिटी बोलते हैं और उसको u लेते हैं. जैसे जैसे वो ऊपर जाता है तो उसका वेलोसिटी कम कम होते जाता है. बॉल का जो स्पीड है कम होता है और एक पर्टिकुलर जगह में आके वो रुक जाता है. तो उस जहाँ पे वो रुकता है उसको बोलते हैं फाइनल वेलोसिटी. सिंस वो रुका हुआ है इसके लिए v विल बी इक्वल टू 0. जब भी रुक जाता है तो फाइनल वेलोसिटी, या जो भी शुरुआत में अगर रुका हुआ है तो इनिशियल वेलोसिटी विल बी 0. यहाँ पे फाइनल में आके रुकता है इसके लिए v इज इक्वल टू 0. और ग्रेविटेशनल फोर्स किधर होता है? वेयर इज द ग्रेविटेशनल फोर्स? द ग्रेविटेशनल फोर्स इज पुलिंग इट डाउनवर्ड. दैट इज वाई द स्पीड ऑफ द बॉल इज गोइंग ऑन डिक्रीजिंग. तो ग्रेविटेशनल फोर्स उसको नीचे की तरफ खींचता है, इसके लिए उसका स्पीड जो रहता है बॉल का वो कम हो जाता है और जैसे वो एक पर्टिकुलर डिस्टेंस में आके रुक जाता है. तो सिंस इट इज गोइंग अगेंस्ट द ग्रेविटेशनल पुल ऑफ द अर्थ, सो एक्सेलरेशन ड्यू टू ग्रेविटी विल बी व्हाट? माइनस g. तो ये ग्रेविटेशनल फोर्स के अगेंस्ट जाता है, इसके लिए एक्सेलरेशन ड्यू टू ग्रेविटी क्या रहेगा इधर? माइनस g. अभी ये बॉल जब भी ऊपर पहुंचता है तो ऊपर पहुंचता है फिर वापस नीचे गिरने लगता है. तो जब भी वो ऊपर रहता है तो एकदम रुका हुआ रहता है. इसके लिए यहाँ पे इनिशियल वेलोसिटी, ये उसका शुरुआत रहेगा. जब गिरते वक्त ये उसका शुरुआत रहेगा और नीचे आएगा तो फाइनल वेलोसिटी. तो इनिशियल वेलोसिटी, यहाँ पे वो रुका हुआ है तो इनिशियल वेलोसिटी u विल बी इक्वल टू 0. और नीचे जब आता है तो ये उसका हो गया फाइनल वेलोसिटी. So this will be the final velocity when it comes down. In the beginning it was standing still, it was not moving. The moment the ball goes up, for some time it moves and the velocity goes on reducing. At a particular distance it stops. So this is the position when it stops. So over here when then it starts falling down. So while falling down, at the top is the initial velocity. Since it is at rest, so u will be equal to 0, and when it reaches down, final velocity will be equal to v. But now the ball is falling towards the gravitational pull of the earth, so the speed of the ball will go on increasing over here. So while falling, the speed of the ball will go on increasing. जब नीचे की तरफ गिरता है वो ग्रेविटेशनल फोर्स के तरफ गिरता है, पुल के तरफ ही गिरता है. इसके लिए बॉल का जो स्पीड है वो बढ़ते ही जाता है, इंक्रीज होते ही जाता है. इसके लिए एक्सेलरेशन ड्यू टू ग्रेविटी ओवर हियर विल बी व्हाट? प्लस g, नॉट माइनस g. इट विल बी प्लस g बिकॉज इट इज गोइंग टुवर्ड्स द ग्रेविटेशनल फोर्स and here it is going against the gravitational pull, therefore it will be minus g. यहाँ पे जैसे ऊपर जाता है तो वेलोसिटी डिक्रीज होता है, कम होते जाता है और एक पर्टिकुलर पोजीशन में आके रुक जाता है. मगर जब नीचे गिरता है तो उसका वेलोसिटी डिक्रीज नहीं होता है, इंक्रीज होता है. क्यों इंक्रीज होता है? क्योंकि इट्स गोइंग टुवर्ड्स द ग्रेविटेशनल पुल ऑफ द अर्थ. therefore here acceleration due to gravity will be plus g. So while doing sums and all, remember this points, and according to the information write down whatever is initial velocity and final velocity, and a according to that you have to take either minus g or plus g. Now gravitational potential energy. Now what is potential energy? The energy stored in an object because of its position and state is called potential energy, which you had studied last year. Now what is the meaning of position and state? Supposing if you have to take the water on top of the building, if you have to take this water on the top of the building, the water can't go by itself, so we have to use a pump. The pump uses electrical energy, and with the help of this the water can be taken up to the tank. But once it reaches, this is known as a position, so when it reaches at this position, whatever energy was used by the water to take it upward is stored in that water as potential energy. So that is known as potential energy. With this stored potential energy, the water can be brought downwards. We don't have to use any pump to bring the water downwards. With the stored energy, that is a potential energy which is stored in the water because of its position, the water can come down by itself. We don't need any mechanical energy to bring it down. So that is the meaning of potential energy. Now when height is small, the potential energy is, formula of potential energy is what? Is equal to mgh. For smaller height from the surface of the earth, if it is taken to a smaller height compared to that of the radius of the earth, the value of g remains constant. So we had studied this, that value of g remains constant for small height, which is very small compared to the radius of the earth. So the value of g remains constant, and it depends upon what? The height and the mass. But at infinite distance, when the h is equal to infinite, the value of g becomes 0. We had studied that as it goes up and up, as the height goes on increasing, the value of g goes on decreasing. At infinite distance, the g is equal to 0. Therefore, potential energy is also equal to 0. Now, when the potential, what is the potential energy when it is thrown at a greater distance? It is equal to minus gmm upon r plus h. What is m over here? Mass of the earth. What is r over here? Radius of the earth. So that is the value of potential energy. Now when a ball is thrown upwards, if you throw a ball upwards, the initial velocity will be u, and as it goes upward, the velocity goes on decreasing, and at a particular point it becomes 0 and the ball stops. So at this position v is equal to 0, and g will be what? Minus over here. Why minus? Because it is going against the force of gravity, that is in the opposite direction. When the same ball starts falling downwards, the initial velocity u will be equal to 0 because it was at rest, and it comes down when it reaches down, the final velocity becomes v, and the acceleration due to gravity over here is plus g because it is going towards the force of gravity, not against. So in this case, the final velocity v is equal to 0, a is equal to minus g. According to Newton's third law, v square is equal to u square plus 2g s. That is, v over here is 0 is equal to u square plus 2. Therefore, s is equal to what? Minus u square upon 2g. So if the initial velocity, if you increase the initial velocity, it will reach at a greater height. So as your initial velocity goes on increasing, the height also goes on increasing. We have studied that when the height increases, the value of g decreases. So if the initial velocity increases, the height also increases. The ball will go at a greater height. So height also increases, but the value of g, as height increases, value of g decreases. So above a particular initial velocity, the height, the ball will reach to such a height that it overcomes the g. So at that position, g becomes 0, and the object will not come back to the earth. It will remain at rest, and it is because it is not affected by g, because at a very high height, when the initial velocity is very high and the height reaches to infinite, that at that position the value of g becomes 0. That means that object is not affected by the gravitational force of the earth or force of gravity. Hence the object does not come and fall down on the earth. It remains at rest at that particular position. Such a velocity is known as escape velocity. Now when you want to throw something upwards, some kinetic energy is required by it to throw it upward. Here the potential energy, when it is on the ground, potential energy will be equal to 0. When it reaches on the top, it will have some potential energy because of its position, but the kinetic energy will be equal to 0. Now same way over here, when it is on the surface of the earth, what will be the kinetic energy? Kinetic energy will be equal to half mv square, that is escape velocity, and over here kinetic energy will be what? kinetic energy will be equal to 0. That is when it is on the infinite distance, where I had showed it over there. Potential energy will be equal to what? Potential energy will be equal to minus Gmm upon R. Why minus? Because it is going in the upward direction. Over here potential energy will be what? Will be equal to Gmm, and at infinite distance. So the value of potential energy will also be equal to 0. Total energy is equal to what over here? Total energy, let us take that as E1. That is equal to kinetic energy plus potential energy. Same way over here, total energy let us take this over here, E2, that's equal to kinetic energy plus potential energy. So E1 is equal to what? Kinetic energy is half mv square escape minus Gmm upon R. Over here E2 is what? E2 is equal to 0 plus 0, so E2 will be equal to 0. Now we know that by the principle of conservation of energy, E1 should be equal to E2. So E1 is equal to E2, that is half mv square escape minus Gmm upon R should be equal to 0. E2 is equal to what? 0. Now take this minus Gmm on the other side. So what you will get? Half mv square escape is equal to Gmm upon R. When it is minus, when it is taken on the side, it becomes positive. M and M will get cancelled. So we will get what? Half v square escape is equal to Gm upon R. Take this half on this side. So what you will get? V square escape is equal to 2 Gm upon R. Now multiply on the numerator and the denominator by R. So what you will get? V square escape is equal to 2 Gm R upon R square. Now what is Gm upon R square? G is equal to Gm upon R square. Therefore in place of this you will put small g, so that is equal to 2 Gr. So V escape is equal to what? Root of 2 Gr. Put the value of G and R, what you will get? 2 into 9.8 into 6.4 into 10 to the power of 6. When you find out the value, you will get what? Escape velocity is 11.2 kilometer per second. So in order to send spacecraft in the moon, if you have to send a spacecraft on the moon or on the other planet, the initial velocity should be greater than the escape velocity. Then it will escape from the gravitational force of attraction of the earth and it will remain there. Now weightlessness in space. Now the spacecraft which is revolving around the earth, it appears to be weightless. Why it appears to be weightless? Over here, the height at which the spacecraft is revolving, the g over here is not equal to 0. The g is how much? 11% than what it is on the surface of the earth. So the spacecraft is weightless not because of the height at which it is, but it is weightless because of the state of free fall. So because of the state of free fall, the spacecraft is weightless in the space. Now, even though the mass of the spacecraft is more than the mass of the traveler, is more than the mass of the object, so all the masses of three different things are different, but the velocity of the state of free fall does not depend upon the properties of the object. Therefore, all appears, all the spacecraft, traveler and object, all is in a appears to be weightless because of the state of the velocity of a state of free fall. Now this spacecraft is affected, why it is in a state of free fall? Because it is affected by only one force. What is that force? Gravitational force of the earth. Now because of the gravitational force of the earth, the spacecraft should come and fall on the earth, but they don't come and fall on the earth because they revolve along the orbit. So because of the velocity along the orbit, the spacecraft don't come and fall on the earth.